In these next examples, we'll focus on converting between rational exponents and radical notation. So first, we've got the 2/9 power. So remember the denominator of the exponent, that's the index of the radical. And the numerator of the exponent is the power. Now, what you can do is you can write this either as, let's write the radical, index 9, and then you've got 4y on the inside. And then you can write that power on the outside, or you can write that power on the inside. So it sort of depends on which situation you're in, like what's the most beneficial to you. I think in one of the last examples, we performed the radical first and then performed the power. In this instance, I think we're going to do the power first and then the radical, just to get it to simplify nicely. And you can do that whenever the expression that you have here on the inside, whenever that's positive, you're able to go in between either this one or that one. The only time that you're not is if the inside of the base that you're raising to the power is a negative number, which then you might have some problems. Okay, so for me, I'm going to use this version. So first I'll take 4y and I'll square it. So I've got the 9th root. 4 squared is 16, and y squared is y squared. And then I can't simplify it any further. This will be the 9th root of 16y squared. So again, I think the only thing you need to think about here is when you're converting to using radicals. If you have an exponent that's where the numerator is something other than 1, make sure that you square that entire base, the whole 4y. A lot of us forget to square the number part of that expression. So just make sure you're squaring that. All right, next example, let's convert this to rational exponents and then we'll simplify. So I don't see the index here. This is the square root of y to the 5th and the square root of y squared. So remember that that's an index 2 radical. So if I want to convert this to rational exponent form, then the top here will be y to the power, numerator is 5, denominator is the index, which is 2. Same thing here with the denominator. This will be y to the power 2 over 2. All right? And then, well, I think what I want to do now is just deal with the fact that this is a fraction, and I should be able to divide by subtracting the exponents. So this will be y to the power 5 over 2 minus 2 over 2. Notice I didn't simplify that 2 over 2 yet because when I subtract with fractions, you need common denominator, so might as well keep it as 2 over 2, right? Alrighty, so 5 over 2 minus 2 over 2 is 3 over 2. So you get y to the power 3 over 2. And we're done. If you like, you could rewrite that as a radical. The index would be the 2. This would be y to the power 3. So you could write either one of these. These are equivalent. Probably for our purposes, this one would be a little bit easier, a little bit better. All right, very last example. Negative 16 to the power negative 3/4. Here's what I want you to notice. What's the base? So here, my exponent is negative 3/4, right? Okay, so that negative exponent tells you that you need to take the reciprocal of the base and then raise whatever that is, raise it to the 3/4 power. Now, notice, what's the base here? Is the base 16 or is the base negative 16? Here's where we need to remember if you have like, say, -5 squared versus -5 quantity squared. Okay, -5 quantity in parentheses squared clearly means that the whole -5 is the base. -5 is the base. So this will be -5 times -5 or positive 25. Now here, only 5 is the base. And then that negative sign just kind of like goes along with the ride. So really what this means is -5 times 5, which is a -25. Okay, so look at the difference between these two things. If you have parentheses around the negative and then raise it to a power, then the negative is included with the base, right? But if you're not including the negative in parentheses with the number that you are squaring or raising to whatever power, then it's only the number part that's raised to that power. The negative negation sign, that with order of operations, that'll come after you square it. Okay, it just kind of follows along, goes along for the ride. So that's what's going to happen here. This -16 to the -3/4 power, 16 is the base. So everything that I do here, I'm just going to tack the negatives at this negative. I'm just going to tack it along. It's going to go along for the ride. So here's what I've got. Negative, and then 16 to the -3/4 power. What I'm going to do is I'll take 1/16 and then raise that to the 3/4 power. Cool? So it's just the 16, right? All right. Now, you could write it like this if you wanted to as well. 1/16 to the 3/4 power. But then I know that 1 to the 3/4 power is just 1. So it's just the 16 that you need to worry about. Okay, so again, I'm going to keep that negative just going along for the ride. It's 1/, now 16 to the 3/4 power. Let me write it as a radical. I'll do the 4th root of 16. And then, because I know I can do that and get a whole number out, after I do the 4th root of 16, then I'll raise it to the power 3. All right, next step. Negative goes along for the ride. 1/, what is the 4th root of 16? Well, 2 times 2 times 2 is 8, times 2 again is 16. So it's 2. So the 4th root of 16 is 2, and then I'll raise that to the 3rd power. So this will be negative, still going along for the ride, 1/2 to the 3rd, which is 8. So that is how that simplifies. Again, notice the difference between this problem, where it was just the 16 that was raised to the 3/4 power, versus, what was the last one we did? This one, where the negative was in the parentheses, so it was really -81 to the 1/4 power. So that one became not a real number, but this one was okay because that negative sign was just kind of going along for the ride.